this session is a frequently asked question session. This is yet another session of our several FAQ sessions in Quant. I hope some of you would have been following our FAQ sessions. This is mainly an interactive, live interactive problem solving session. So this is here we'll be dealing with today's session on permutations combinations, the much discussed topic and what students normally find little difficult. So as you can know already, I know that most of you are GRE aspirants, and so you must be having a fair idea of what topics will be tested in Quant in GRE, right? So as you would have seen, most of the topics are nothing but whatever you had studied till your grade 10, right? Most of the topics tested in GRE. They test, GRE it's not a knowledge-based test, it's a skill-based test. So normally GRE questions will be framed in such a way that they would test on how well you are able to apply the concepts that you had learned rather than on knowledge. It would not be an extensive or tedious problem solving. How well you are going to apply the techniques, that is what matters in GRE. So the few topics that are little harder, which you to have not learned till your 10th standard, permutations and combinations, standard distributions, normal distributions, there are only 2 or 3 topics that are not there covered till your 10th. That will be like higher secondary topic, a little higher topics. That is what normally students find hard to internalize or conceptualize those topics. So this comes, as you know, practice makes a man perfect, and perfect practice helps you to get a perfect score in Quant. That is the aim of this frequently asked questions. As you solve more problems, apply the strategies properly and make sure that you understand that GRE is a timed test and be conscious of the time and then learn to solve the problems. Then it becomes easier for you to tackle any kind of problems, right? So, permutations and combinations. First of all, students do not have a clear idea of what this topic is all about. Permutations, combinations. This is to do with simple counting. Simple counting in a complex jargon that's defined as permutations and combinations. So what is permutation? What is combination? When you choose some objects from a given sample of objects, that's called as a combination. But after choosing, suppose you're going to rearrange, that's called as a permutation. To put it in simple terms, permutation requires ordering, combination does not require any ordering. So let me give you a simple example to get started with what permutations, combinations, and then really get started with our session. So suppose I'm asking you, I have a basket full of cards, say cards with letters A to Z. My question would be, just choose 3 cards from these letters. The answer would be 26C3, which is a combination. On the other hand, suppose I'm asking you to form a 3-letter word with or without meaning using those 26 alphabets put in the basket. Then it becomes a permutation problem, because when I'm going to form a 3-letter word, suppose I'm going to say pick O-R-E. So A-R-E. Suppose I'm going to pick 3 letters A-R-E. Right? So when I just choose, it is just 26C3. But if I'm going to form a 3-letter word, I could have it as R-A-E, E-A-R, A-R-E. So different permutation, different rearrangements of those letters is possible. Right? That is 3 factorial rearrangements are possible. Then it becomes a permutation problem. Sequencing matters. So that is the basic difference between a permutation and combination. Permutation, ordering matters. Combination, ordering does not matter. Now, before we move into the real problem solving, I just want you to briefly understand the common mistakes that students do regarding permutations and combinations. A very common mistakes we would at Galvanize, we categorize into 3 parts. One is multiple counting. The other is confusion of powers. Third one is identical objects. Now, those who have enrolled with us, they know that there are extensive sets of problems identifying each of these mistakes, like possible mistakes that you can make, right? So there'll be like, say, for multiple counting, there are several sets of problems for multiple counting. Confusion of powers. to get rid of those mistakes that you commonly make in permutation combinations. There'll be lots of problems on our platform. Those who have enrolled with us, they would know it. I think Maunal Mystery is one of our enrolled students. I think you must be knowing about the varieties of problems that we have on the platform. So in this webinar, I'm just going to give you an example of one of the common mistakes and how to go about avoiding that mistakes. And then we'll start with the real problem solving session. I hope it's fine with you. Yes. So let me explain to you what this multiple counting is. Why is it called as a mistake? Let me give you a simple example here. There are 10 books on a shelf, of which 4 are paperbacks and 6 are hardbacks. How many possible selection of 5 books from the shelf contain at least one paperback and at least one hardback? Right. There are several ways to solve this problem. That is what students think. And most of the students make this mistake. Since the question says at least one paperback, at least one hardback, they would fix this one. That is, from 4 paperbacks, you can choose 1 and 4C1 ways. And from 6 hardbacks, you can choose 1 and 6C1 ways. Right. Now, those two fixed. Since the question says at least one hardback, at least one paperback, the remaining could be a paperback, could be a hardback, right? More than one hardbacks could be there, more than one paperbacks could be there. So the next would be, they would multiply it with the remaining 3 chosen from the remaining 8. 2 books are already taken. So out of 10 books, 2 taken. So remaining is 8. We need 5 books to be chosen. So you need to choose the remaining 3 books from the remaining 8 books. That is done in 8C3 ways. Right. How many of you can type it in the chat box? How many of you feel that this is the approach that you had been following? Be honest. Just try to be honest. Anyway, I'm going to explain to you. You know, I've written that this is a wrong approach. I'm going to explain to you. All along, if you have been following that approach, try to change it, because when I explain to you, you will understand that you are actually doing a multiple counting when you follow this approach. Yeah. Please explain. Again, I have not explained the problem yet, Dharman. This is a very common mistake that students make. It says that at least one paperback and at least one hardback. They would say 4C1 times 6C1 times 8C3. That is, pick one paperback, pick one hardback. Then the remaining 3 have to be picked from the remaining 8. That would be 8C3 ways. So 4C1 times 6C1 times 8C3 ways. Clear? But this is wrong. This is a wrong approach. Okay, let me tell you why this is wrong. Instead of 10, I'm going to take a simple example so that I can list it out so that you understand it better. Instead of 10, I've taken 4 books. Suppose there are 4 books with 2 paperbacks A and B and 2 hardbacks C and D. Here, we have to select 3 books from these 4 books, out of which at least one paperback and at least one hardback book is there. Clear? So according to your instinct, you would do it as 2C1 times 2C1. 2 books are already selected. From the remaining 2 books, select 2 books. So 2C1 times 2C1 times 2C2. That is what you would do. I have listed the way that you normally select it. Out of 2 books, you're going to choose one. It could be A or B. That's your first step, right? So suppose you are choosing A from 2 paperbacks. I've taken that A from the 2 paperbacks. Now, with the A, I could go for C from the hardback or D from the hardback. Clear till this? Yes? Yes, guys? Have you all understood till this? Now, with this C, I've selected A, I've selected C. Assume that I've selected A and I've selected C. I've selected one paperback, one hardback. Then what do? There are remaining 2 books. You could choose anything from those 2 books, right? I need 3 books. That is the purpose here. That is the way you solve it. So AC is chosen. Then I could go for B and D, right? I could choose B and D or AD with BC. So if you can look at it, I've listed down all the possible combinations here. I could select one paperback, one hardback. That after fixing that, I'm going to choose 2 books. That would be B and D. Or I could select one paperback, one hardback, that is A and D, and choose the remaining B and C. If I do that, I have listed all the possibilities here: ACB, ACD, ADB, ADC, BCA, BCD, BDA, BDC. Can you infer from this listing? This is based on the common mistakes that students do. This is what exactly that students do, right? They have if I list everything, can you identify that you are actually double counting here? You're choosing 3 books. I'm not talking about an ordering here. If you look at it, ACB is same as BCA, right? ADB is same as BDA. Clear? BDC and BCD are the same. ACD and ADC are the same. This is what precisely happens when you do this. That is, take one book from each category and take the remaining books from the remaining set of books, total books. Clear? So when you do it that way, definitely you're going to double count like this. This is called as multiple counting mistake. You will definitely end up with a mistake like this. As you can see, ordering does not matter here. The question is asking only about choosing, only a combination question. So hope you are clear with the mistake that is happening here when you do it that way. Just choose one book and the remaining. Don't do it like that. This is a kind of mixed problem. How do you go about solving this problem? I hope till this everybody has understood what is the mistake that happens when you're going to choose one and then the rest of the items. Clear till this? Yes, guys? Right. So how do you avoid such a mistake? As Dhruv has rightly put, you go for a mix and match. That is a very important strategy for these kinds of problems. When you have 2 or 3 more categories in a given question, then you have to go for this mix and match. That is, I select 1 book from paperback and 4 from hardback, 2 from paperback or 3 from hardback, 3 from paperback and 2 from hardback, or 4 from paperback and 1 from hardback. This is how you have to proceed. There is no second method for this. This is the only method. This is the best method to follow for this kind of questions. You should not do that picking that one at a time. Just pick 4C1 times 6C1 and then the remaining 8C3. No, that is not going to help you at all, because you will end up with the double counting. That mistake will happen when you do it that way. That is the reason I've listed it down with a simple example here. I hope it's clear for you. Yes. So the best way to solve this kind of problem is to go for a mixed strategy, mix and match from the set of books that's available. Clear till this? Okay, guys, are you all ready to solve the problems now? I hope you all have your paper and pen with you. Shall we start with the problem solving session? So I'm going to shoot a question on the screen. I'll give you 1 to 1.5 minutes. That is the maximum time that can be allotted. Now, these kinds of questions in permutation combinations are either a MCQ or a MAQ. Yes, Jagadish, that's perfectly right. It's not 1 minus. You're not talking about a probability here, Jagadish. It's not 1 minus. It's the total number of permutations. That is 10C5 minus of 4C0 into 6C5 plus 4C1 into 6C4. Perfectly fine. That is also acceptable. Not 4C1 into 6C4. It's 4C0 into 6C5 minus. So this will be 4C4 times 6C1. That's not possible. 4C1 into 6C4 is there. I've listed that here. Clear? So it's not 1 minus. Again, I think you're confusing between probability and permutations combinations here. This is a permutation combination question. It's not a probability question. So the total value is not 1. The total is the total number of ways you can select 5 books from 10 books. That is 10C5. Got it? Jagdish, I hope you understood your mistake. Okay. So moving on to the problem. I hope you're all ready. The first problem is here on the screen. Let me move on with the answer. Okay. So a particular numeric log can be set to open with a 6-character code. Yeah, Divya is right. I think Dhruva also got the right answer. The first 2 characters have to be letters. So the first 2 characters have to be letters, and the last 4 have to be digits, that is the numbers that's given to you. Now, I think there is a format mismatch here. So first 2 have to be letters, and it has to be a different character code, right? They are not allowed to repeat. The digits and alphabets are not allowed to repeat, which means the first letter can be chosen from any of the 26 alphabets in 26 ways. So 26 times, 25 times, 10 times, 9 times, 8 times, 7. This is the total number of codes that can be generated. The first place has to be a letter, second one has to be a letter, and the next 4 places have to be numbers. Numbers starting from 0 to 9. There are 10 digits that can be filled in each of these 4 places. 10 times, 9 times, 8 times, 7, because the digits should not be repeated and the alphabet should not be repeated. In case a question says the digits and alphabets can be repeated, the answer would be 26 times 26 times 10 times 10 times 10 times, and that is 26 square times 10 power 4. That would be the right answer here. So I've done it in 3 ways here. One is just the fundamental principle of counting. Fundamental principle of counting states that you just have to multiply the number of ways that you can fix here. Like for every slot, how many different possibilities are there? You just have to write it down and just multiply the numbers. That is called as fundamental principle of counting. So 26 ways for the first slot, 25 ways for the second slot, 10 ways for the third slot, 9 ways for the fourth slot, 8 ways for the fifth slot, and 7 ways for the sixth slot. That would give me this answer by permutation formula. Permutation formula, you are out of 26 alphabets, you're going to pick 2 alphabets and then arrange them. That is done in 26p 2 ways. And out of 10 digits, you're going to pick 4 digits and arrange them in 10p 4 ways. So 3,276,000. That's the answer here. By using combinations is 26c2 times 2 factorial. Why is this 2 factorial? Because after you choose 2 alphabets from 26 alphabets, then you need to rearrange those 2 alphabets that you have chosen. Again, after you choose 4 digits from 10 digits, then you have to rearrange them. When I say rearrange, what does it mean? From 26 alphabets, suppose I'm going to pick A and B. Now, first slot can have A, second slot can have B, or the first slot can have B, second slot can have A. There are 2 factorial ways of rearranging it. And 10c 4 times 4 factorial. Again, if I'm going to pick 0, 1, 2, 3, 4. Assume that I'm going to pick 0, 1, 2, 3. Then I could also write it as 2, 1, 0, 3, 3, 0, 1, 2. So different ways of rearranging all the 4 digits is also possible. So that is why you multiply by 4 factorial. You can use any of these methods, whichever you're comfortable with. The next problem is a multiple choice question. A jar contains 24 marbles, 6 red, 8 white, and 10 blue. If you pick marbles one at a time randomly, what is the minimum number that must be picked to be certain that you have at least 2 marbles of each color? This is a multiple choice question. Only one of these will be the right answer. So please apply the strategies for multiple choice questions. There were several frequently asked question webinars on how to tackle MCQs. Some strategies are there to handle multiple choice questions. If you are familiar with those choices, please try to implement those. That's very important. Familiarizing with the strategies to solve different question types in GRE, or for that matter, any time test, is very important. So MCQs, as I've been reiterating in all my sessions, back substitution is one of the strategies that we teach, we enforce in Galvanize. That's very important to solve MCQs. So the question is asking which of these can be the minimum number. Suppose I start with the minimum number as 6 marbles. Now all 6 can be red, which means I don't have 2 of each color. So this means I can eliminate that option A. Clear? Now if I go for option B, which is 12, if I say the minimum number is 12, then I could have 6 red and 4 white, which means I'm ignoring blue, or I could have 10 blue and 2 white, which means I can ignore red. Some kind of combination, at least one of the colors can be ignored, right? You cannot be certain that all the 3 colors are picked when you're going to have 12 marbles in your hand. Got it? The 12 need not have all 3 colors. I'm trying to say that 12 can be all 10 blue plus 2 white, or it could be 10 blue plus 2 red, or it could be 6 red plus 6 white, right? So one of the colors can be ignored. There is a possibility that you could ignore one of the colors when you're going to choose option B. Option C, if the minimum number is 16, as I just told to Dhruva, when you're going to choose 16, the third option, then it could be just 6 plus 10, which means you could ignore 8. You could have ignored 8, or if you're going to say 16, you could choose 6 from white, and all the 10 blue, you could have ignored red. Quite a possibility that you are not choosing all the 3 colors, right? If you're going to choose 18, again, the same mistake might happen. You might ignore another colors, the other colors. You could just have all blue, all white. You could have ignored red colors. So we go for option E. When I say 20, so obviously if I am going to choose 6 red plus 8 white, that will be 14. I need to choose 6 more. That has to be from blue. Obviously, you will have 2 of each color. If you're going to choose all blue and all white, definitely you need to go for 2 more from the 6 red. If I'm going to choose all red and all blue, definitely you need to go for 4 more from the 8 colors. From the 8 white. Got it? Got the strategy? This is actually a very simple counting technique. Normally, this is a part of arithmetic, right? But these types of questions are figuring under data analysis section in GRE. This is a very typical data analysis question in the actual GRE. Okay, so I hope you are coming. This is a very simple aptitude question if you look at it. Nothing, no combinations, nothing. I've not done any calculations here. No combination, no permutation. This is just a general aptitude question. So be prepared to face such questions also in GRE. It is just the way you're going to choose and combine the elements here to come up to the number that we are looking for. Okay, the next question is this. This is again a multiple choice question. Exactly one answer choice is the right answer. In how many ways can 21 identical books on English and 19 identical books on Hindi be placed in a row on a shelf so that 2 books on Hindi may not be together? So there are 2 things that you need to understand here. One is the question is asking for, question has given information about identical books. 21 identical books on English and 19 identical books on Hindi to be placed in a row on a shelf so that 2 books on Hindi may not be together, right? They are identical books. So definitely when you're going to permute the 21 books, it will be 21 factorial by 21 factorial. When you have say 2 identical elements or 3 identical elements in a bunch of 5 elements and you're going to permute them or rearrange them, then it would be 5 factorial by 2 factorial divided by 3 factorial. That is a formula for permutation. That is how the rearrangements where the objects are repeated behaves, right? To exclude or not account for repetitions, we have to divide by the number of repetitions in case of permutations. So in this case, when you have 21 identical books on English, 19 identical books on Hindi, you don't have to rearrange them. You don't even have to think of rearranging them because they are just identical books. So you have to find out the number of ways in which no 2 Hindi books are together. Hindi books may not be together. The best way to solve this problem is to first fix the ones that is not a variable. Variant here is the number of Hindi books. So you fix the English books here. The question is asking about Hindi books. Therefore, I fix the English books here. I could start with the English book or I could start with the Hindi book. As you can see, X stands for Hindi books, E stands for English books. So once I fix the English books, there are 21 English books. Once I fix them, as I told you, again, I'm not going to permute these English books. Suppose the question says 21 different English books. Definitely it has to be 21 factorial. But then all these are identical. There is just one way to fix all these English books. 21 places you put all these English books, and then the remaining places that could be placed before English, after English, in between English books. You're going to place the remaining Hindi books. That would account for not having the Hindi books together. So how many places are there between English books, before English book and after English book to place the Hindi books? There are 22 places. In those 22 places, you need to choose 19 places to allot for the Hindi books. That is done in 22C19. which is same as 22C3. NCR is same as NCN minus R. That's the formula for combinations. That is equal to 1540. When you do the calculation, you will arrive at the answer 1540. Very good. Good job, Abhishek and Nurain. Everybody else, did you understand this problem? Did you understand how to approach this problem? It's a very simple problem. So one thing that you need to be very careful here is they are all identical books. If the question had been asking about different books, then definitely we will go for 21 factorial. Since they are identical books, there is just one way of arranging all these English books. That is 21 factorial by 21 factorial, which is equal to just 1. I hope you're all clear with this. Since 19 identical Hindi books, but we can't divide 19 factorial. No, see, you're not rearranging anything here, Jagadish. You're just choosing out of 22 places, you need to choose 19 places. I'm not doing anything with the books here. I'm just picking 19 places from the allotted 22 places here. That is done in 22C 19 ways. That's all. 19 factorial by 19 factorial gives you 1, right? There is no way, you don't even have to look for rearranging the books here because they are all identical books. Got it? So all you need to be bothered here is just to choose 19 places to put these 19 Hindi books out of the possible 22 places. Got it? That is done in 22C 19 ways. That is 1540. You can definitely divide by 19 factorial. It's 19 factorial by 19 factorial. That will be the total number of permutations of 19 identical Hindi books. So the answer is 1540. In how many ways 12 different books can be distributed equally among 4 persons? This is a very, very simple problem. If there were 3 identical English books, then you divide, it would be 21 factorial by 3 factorial. Only 3 identical English books, the rest of it, yeah, others were not identical. Then the previous question, you will have to do it as 21 factorial by 3 factorial. That would be the answer here. That will be the total number of different arrangements of the English books. Got it? So the answer would be 21 factorial by 3 factorial times 22C 19. Yeah. In how many ways 12 different books can be distributed equally among 4 persons? It's a very simple question. I think you should be able to solve it within a minute. 12 different books distributed equally among 4 persons. Obviously, this means that each person should get only 3 books. That's what it means. 4 people, each person can get only 3 books. How many ways can you choose 3 books from 12 books? That is done in 12C 3 ways. And 3 books are already chosen. So remaining 9 books, again you choose 3 books in 9C 3 ways. Again, 3 books from the remaining 6 books in 6C 3 ways. And from the remaining 3 books, you choose 3 books in 3C 3 ways. The answer is 369600. Why not 12 factorial by 3 factorial? Why is it wrong? 12 factorial is rearranging all 12 books. 12 different books can be rearranged in 12 factorial ways. How do you account for distributing it among 4 people? Each person gets 3 books. When you say 12 factorial by 3 factorial, why is that 3 factorial here? Why are you dividing it by 3 factorial? It is not 3 of one kind, right? You are distributing it to 4 people here. They are not same books. Only if they are similar books, there are 3 similar books, you divide by 3 factorial. That part, it's not very clear, Benedict. 12 factorial by 3 factorial doesn't make sense at all here. There are 12 books. You're going to distribute them equally. They are not the same books. There is no need to divide by 3 factorial here. Got it? Simple, plain question. You just have to distribute it to those 4 people equally. So each person gets 3 books. Now, how do I account for the fact that each person gets 3 books? How do I choose those 3 books for each person? That is done in 12C3 times 9C3 times 6C3 times 3C3 ways. A girl, again, this is a MCQ. A girl has 3 library tickets and 8 books of his interest in library. Of these 8, she does not want to borrow Physics 2 unless Physics 1 is also borrowed. In how many ways can she choose the 3 books to be borrowed? This is a little above medium level question. Not a hard question though. Little long time for you to think more and understand and then solve this problem. Please look at the wordings carefully. Now, this is how the questions are worded in actual GRE. The questions are little ambiguous. It will not be straightforward. The wordings will be little confusing. That is how they tend to word the question, because the concept is actually very simple. So they throw all those trap in wording the questions just to confuse you. A girl has 3 library tickets and 8 books of his interest in library. Of these 8, she does not want to borrow Physics 2 unless Physics 1 is also borrowed. In how many ways can she choose the 3 books to be borrowed? Let me look at the solution here, give you the solution here. Okay. A girl has 3 library tickets and 8 books of his interest in library. Of these 8, she does not want to borrow Physics 2 unless Physics 1 is also borrowed, which means if Physics 2 is borrowed, you can be rest assured that Physics 1 is also borrowed. So I'm going to consider several cases here. Case 1 would be both Physics 1 and 2 are borrowed. So which means the remaining 3rd book, she has to pick from the remaining 6 books. That is done in 6C1 ways. Got it? Case 2, Physics 2 is borrowed. When I say Physics 2 is borrowed, the question says she does not want to borrow Physics 2 unless Physics 1 is also borrowed, which means if she has borrowed Physics 2, it means Physics 1 is also borrowed. So this is same as case 1. Got it? Case 3, you assume that Physics 1 is borrowed and the second book can be Physics 2 borrowed or it cannot be Physics 2 borrowed. I have 2 cases under case 3 itself. Case 3, I'm going to split it in 2 parts. One is case 1, Physics 1 is borrowed, and out of the remaining 2, I could have Physics 2 or I need not have Physics 2. Including everything, I will have remaining 7 books. I have to choose the remaining 2 books in 7C2 ways. These 2 books can have Physics 2 or may not have Physics 2. I don't know. Clear? Clear till this? Or explicitly, I would say that I'm going to exclude Physics 2 and then just choose from the 6 books, the remaining non-physics books in 6C2 ways. So either 7C2 or exclude Physics 2 and choose it in 6C2 ways. Or case 4, both Physics 1 and Physics 2 aren't borrowed. So the remaining 6 books, because 2 books are eliminated here, from the remaining 6 books, I have to choose all 3 books. That is done in 6C3 ways. So the answer would be 6C1 plus 6C2 plus 6C3. Now 6C1 plus 6C2 is same as 7C2. NCR plus NCR plus 1 will be same as N plus 1 CR plus 6C3. The answer is 41. Got it? The same question. If you are confused with this, I always have a table. Now, table is a very good representation of understanding word problems. Normally, when we solve word problems, we always insist on a strategy called as PIE, P-I-E. Divide the word problem into parts, collect and connect the information in the form of a table or draw a diagram, and E is framing the equation. Albert Einstein, one great physicist, he once said that it takes 99% of the time for you to just understand the problem, just 1% of your time to solve it. Solving it is very simple, provided you first comprehend and try to figure out what is given there and then put it in a form of table or a diagram. It becomes very, very easy for you to solve. So here I have listed all the cases. Physics 1 borrowed, Physics 2 is borrowed, non-physics, that is 6C1 ways, right? Got it? Which means Physics 1 and Physics 2 are fixed. The remaining, from the 6 remaining choices, I'm going to choose 1 non-physics, that is done in 6C1 ways. Physics 2 is borrowed, which means Physics 1 is also borrowed. Third one is a non-physics books. Again, it's the same as the first one, which is 6C1. Physics 1 is borrowed. Second one can be non-physics. Third can be non-physics. Or I could have Physics 2 and non-physics. Now, when I have non-physics and non-physics, 6C2. When I have Physics 2 and non-physics, it boils down to the same as case 1, again at 6C1. Or all the 3 non-physics, which is 6C3, which means you are eliminating Physics 1 and Physics 2. So remaining 6 books are left out. From those 6 books, you need to choose 3 books. That is done in 6C3 ways. Got it? So the answer is 41. This is actually a very simple problem, provided you learn to draw this diagram like this. You learn to draw a table. It becomes very simple for you to solve it. So the answer is actually 6C1 plus 6C2 plus 6C3. Moving on to the next sum. In how many ways can you distribute 3 prizes, each a dollar coupon, $100 coupon to 10 people. It's a very simple problem. You can solve it in a few seconds. 10C3 is the right answer. It's 120, right? So as I told you, the order does not matter here. Since it's the same price that's going to be distributed to 10 people, you just have to pick 3 people from the 10 people to give away that price. That is done in 10C3, which is 120 ways. Wonderful. Next question. Very, very commonly asked question in GRE. Very common. Most of the GRE papers, if you look at it, there'll be at least one question of this type. In how many ways a team of 2 with a class leader and assistant class leader can be chosen from a class of 12 boys, 12 girls, and 13 boys? Very simple question, but very common question in GRE. Okay. Now, in how many ways a team of 2, which means there are only 2 people in the team. Others, we do not know how many members are there in the team. Let's not bother about it. With the class leader and assistant class leader, the moment we impose a designation, it means that it is a permutation problem. Ordering does matter here. The moment we have captain, vice captain, class leader, assistant class leader, right? Something like that, some role or designation, if you're going to impose in the question, then it is a permutation question. The sequencing or the ordering does matter here. So out of 25 students, 12 girls, 13 boys, you don't have to split it as 12 girls separately, 13 boys separately. As I told you, this is a mixed problem. You just have to combine everybody, 25, because I did not say anywhere that the class leader has to be chosen from the girls and the assistant class leader from the boys. It is a simple question where you're going to choose class leader and assistant class leader. Just to confuse you, the split up of the number of girls and number of boys is given in the question. There are totally 25. From 25, you're going to choose 2. That is done in 25C2 ways. But then the 2 that you're going to choose, class leader, assistant class leader, it matters because the ordering matters because it's a designation here. The first could be a class leader, second could be an assistant class leader, first could be an assistant class leader, second could be a class leader, right? So it's 25C2 times 2 factorial. This is the answer, right? Or you don't have to necessarily follow this. It's 25 times 24. That's all is the answer here. 25 times 24 is 600. That 12 girls and 13 boys, that split up is given only to confuse you. Nowhere it's given that you're picking those 2 from the 12 girls or from the 13 boys, right? So this is a mixed problem. So you should be very careful. When such a restriction is not given, you can be rest assured that you're going to combine everything, put it in one bucket, and then pick from that. So I hope this session was useful to you.